Hey, welcome back. Welcome back to the second part of our videos where we wanted to talk about these two specimens here, and we're dealing with carburization topics. As promised, I've found out what happened. So stay tuned. So one more additional information that I forgot about it. So these two specimens we are talking about, not all of the tubes are affected by these black stain, right? So it's roughly 20 of these and 20 lengths of those. And the other parts of the lot we received from our supplier are totally fine. So it's just a small average of material that is affected and some is not. And my question certainly is, why is that happening? And after finding out and talking to our supplier, one part of both of these dimensions have been produced in one shift, and the other parts have been produced in the consecutive shift. So in this shift change, something has happened. So apparently there was like a miscommunication between shift 1 and shift 2 about the task of degreasing. And apparently this part of taking off these manufacturing lubricants from the surface of the stainless steel got lost in between those two shifts. However, the consecutive step of annealing did happen with non-cleaned pre-material. And that's the reason why the later on batches or the later on tube length, they got produced in a very well and continuous way. But during this shift change, something has happened. And this is the reason. So a very simple reason, actually a miscommunication happened, and that caused this carburization effect. And I would like to reintroduce, so to say, a bit the samples which are non-affected. Then we had the slightly affected one that we got as a delivered condition from this bad specimen that you can see here. And we even pickled that material. And this is what you can see up here. And the question that we were asking ourselves is, how does that affect the material? How deep goes the effect into the material itself? So you need to know that during a pickling process, and this is what we have seen, that we so much develop this effect, that a standard pickling process goes just 3 to maybe 5 micrometer, maybe even a bit less into the material. Yeah. So let's assume 3, and there we develop this more and more. So it's certainly going down further than 3 micrometer into the material. And we know that we can also apply a slight electropolishing process onto the material to go down a bit deeper. So in case we apply that, we would go down roughly 5 micrometer into the surface. And the 5 micrometer specimen is what I have in hand here. And this one looks already kind of bright. It looks kind of shiny, but still there's a difference between a full electropolished material and a specimen like this. And when you look at it on a microscope, you will find it up here, and you see that you still see the grain boundaries very, very visible. So I wouldn't say it's the same as with the pickled one, but you still see these grain boundaries very well. And why does that happen? Because the material of stainless steel is a lot more corrosion effective, so to say, has a lot less corrosion resistance, probably that's the better term, towards the other material. And that's why the electrolyte and the attack of the current goes at these grain boundaries deeper into the material as on the grain, where you don't have that much chromium carbide, right? And in case you do a full electropolishing process, which goes down roughly 20 micrometers into the material, you will see a very nice and shiny surface appearing. And when you take a real close look at it, you still see the grain boundaries, but these are the standard grain boundaries of the austenitic stainless steel crystallographic orientation. So we know that when we take a look at it and do the pickling, we do the slight electropolishing, we do a full electropolishing process, we see this process, so to say, developing and also disappearing again during a full EP. So we can see that after a full EP, this effect of carburization is basically gone. So my estimation would be that we are talking roughly of a deepness of maybe 15 micrometer into the surface of the carburization, means chromium carbide formation, means a lack of corrosion resistance of the surface. And that's what we should consider here. So the material is not corrosion resistant as other material. And we have figured for now what happened. We see why it happened. We see the result. But do we actually know about the impact? I believe in my first video I was talking about a possible gas application that might not be that critical, but a application for a liquid or critical liquid might certainly become more critical. And can we quantify that? But this is something we're going to find out. Is there an effect to the corrosion resistance? So stay tuned and certainly stay curious. See you around.